All right, guys. So yeah, we are gonna go ahead and start chapter 9 today. It's gonna be one of our shorter ones in terms of like number of sections that we've covered all year. So we'll do 9-2, 9-3, 9-4, 9-5. And there's like an easy pattern to see in them. It's all about sequences and series. Um, it's kind of, I guess, a little bit disconnected from what we've been doing, but it's more of a prep for pre-calc kind of unit. It's not the math that's real difficult, but just kind of knowing what you're being asked, knowing how to speak the language, understand the notation and stuff like that. So that's a big part of it. We start out with a pretty easy one today, which is arithmetic sequences. And it's a lot of pattern recognition and stuff like that. Okay. All right. So one kind of notation that you'll need to understand is we use a lot of subscripts, so that you would read that A sub n, and that just tells you which term in the sequence we're talking about, right? So some examples: A sub 1 is the first term in a sequence, A sub 30 is the 30th term, and so on and so forth. So yeah, n just tells you what term we're talking about. Okay, so we'll go ahead and get right to it. Example 1 wants us to find the first 5 terms of a given sequence, and we're given a rule here. The rule is 5 times n minus 3. Just so we can get used to using the notation here, we'll say A sub 1 is, that would just be 5 times 1 minus 3, which is 2. A sub 2, sub n 2. 10 minus 3 is 7. And then basically, at that point, we can see we're pretty much just counting by 5s, right? So A sub 3 would be 7 plus 5 is 12. A sub 4, 12 plus 5 is 17. And then our fifth term, A sub 5 would be 22. So there's always that kind of linear pattern with these, okay? And then example 2 is a little bit different because they don't give me an explicit rule to follow. So we have to first recognize the pattern and then go from there. So that said, looking at example 2, can anybody tell me what the pattern is? Like, what am I counting by? Decreasing by 5, right? So that's your success level in this is, the quicker you can kind of recognize that, the better off you're going to be, right? So our next term, we could call it A sub 5, or we can just do like fill in the blank. Would be negative 9 minus 5 is negative 14. Negative 14 minus 5 is negative 19. And then negative 19 minus 5 is negative 24. Okay. If it's ever difficult to see that we're decreasing by 5 every time, you can just take a term minus its previous term, and that'll give you that pattern, right? So if I took like 1 minus 6, that would equal negative 5. If I took negative 9 minus negative 4, that would give you negative 5. Okay, so if you can't see it, you can figure it out that way. Sorry about that. All right, so that's all for the front side. That's an introductory kind of thing, and it's similar to our examples today, so it does tie in. So if you want to go ahead and flip over to where it says, yeah. Yeah. No, 5. It just said, sorry, I kind of glossed over that. Yeah, that's why I did the first 5. Yeah. That makes sense? Okay. All right. So anyways, on the back side here, talking about, we get a little more formal now. So an arithmetic sequence, an arithmetic sequence is a sequence where the difference between consecutive terms is constant. That difference is referred to as the common difference, which, we call, we use the variable d. That's kind of the same thing as like if we were thinking about the graph, it would be the slope of the line. So that's the same as the slope, or m. And so there you go. All right, so linear growth, that would be an arithmetic sequence, okay? All right, so given this sequence right here, 4, 7, 10, 13, keeps going, what would a sub 1 be? That would just be whatever the first term is. So we would say that's 4, okay? And then d is basically the pattern, right? So we are counting in this case by 3, right? So d equals 3. Okay, and again, that's because 4 plus 3 is 7, and so on and so forth. Okay. All right, so in example 1, the question is, do we have an arithmetic sequence? If so, what's the value of d? What's the common difference? All right. So you do need to make sure it works, all the way through. So like looking at A, I know 1 plus 3 is 4, and I just want to make sure 4 plus 3 is 7. Yeah. And 7 plus 3 is 10. So since it works the whole way through, we would say, yes, it is an arithmetic sequence. And we would say D equals 3. Right? D just describes the pattern. Okay. Now looking at B, first of all, before we answer the question, is there a pattern that you can see? Right, yeah, so that pattern would be what? Multiply by 2. They're doubling every time. But the answer to is it an arithmetic sequence is no, okay? So that's kind of a trap problem. Even though we can see a pattern, it's got to be a common difference. So here it's plus 2. Here it's plus 4, right? So we would just say this is a no. And that's kind of a preview of what our next type of sequence is going to be, geometric sequence. All right, anyways, you go ahead and answer C. So is it an arithmetic sequence? If so, what's D equal to? And you guys feel free to compare. I'll probably call on you a little bit today, just so you know. Sometimes I don't, but I think we should have time to do all that today. All right, Taylor G, did you think this was arithmetic or no? Yes, I agree. And it is because the common difference is what? Sorry. Yes, I think you said -6. Yes, that would be correct. So yeah, decreasing by 6, so D equals -6. And again, hopefully you can just kind of see that. If you can't, then you take -5 minus 1 or -11 minus -5. That'll give you the -6, okay? All right, moving on. Anybody got any questions before we move on? Okay. All right, so then find the next 3. We've already kind of done this. We could easily skip this example, but we'll do a few more, So, all right, so here we're going to find a sub 4, a sub 5, a sub 6. Not that we have to use that notation. But again, we can recognize that the pattern is that I'm adding what each time? 5, good. And so our next term is going to be whatever 22 plus 5 is, right? So 27. A sub 5 is going to be 27 plus 5, or 32. And then our last term, bless you, that we're going to write out is going to be 32 plus 5 is 37. You don't have to use that notation here. You could just do, number, comma, number, comma, number. All right. Anybody want to kind of fill in the blanks for me? Anybody have that for me on B yet? Sam? 7, 11, 15. That's right. Okay. So quick, you don't have to write out a bunch of work here. It's just pattern recognition. All right. So I'll give you guys half a minute on the next one. Goes from 12 to -3 to -18. So what would the next 3 be? And of course, it kicks me out. Okay, never mind. No, it didn't. That's just gonna be an awkward part of the video right there. I guess it does. I guess it just says like, just in the middle. Just, are you still there? I don't know why. I would assume I wasn't. All right. Let's see. Bless you. What are the next 3? So have to recognize there that the pattern is -15. Parker B. So if you were using -15, what are the next 3? Uh-huh. Bless you. Anybody want to help? There you go. Very good. All right. So anybody need any help with those types of problems, or you guys kind of got it? All right. So something to consider here. What if you were asked to find the 11th term? So what we've been, if I can talk, what we've been doing so far is, or what we did in the previous example would be called, we're taking a recursive approach. So to find any term in a sequence, we need the previous term, right? So to use a recursive approach here, we would need a sub 10 to find a sub 11, okay? Which is fine, you could do that, all right? But this method has its limitations, right? If I ask you to find the 625th term, that's not going to work, right? We're not gonna do all that writing. So what we want to do to find the nth term, I think this may be on the next side. So basically, we're not going to answer it this way, so we don't really use this approach too much to find the nth term. Maybe to find the next 2 terms or something. But instead, we'll do the same problem using an explicit formula. So this is the first thing from today's notes that is on your formula sheet, which you haven't gotten yet, but you will. Okay, and you'll be able to use that on the test. So it's kind of funky looking, but it's also very similar to like y equals mx plus b. So it's similar to. So the difference would be kind of, we think of our starting value of a linear function as when we plug in 0 and we think about the y-intercept, whereas here would be we plug in 1. So that's why that n minus 1 is built in there, okay? And that's the key thing people mess up when they use this formula wrong, is they'll be 1 term off because they forget to do the minus 1. So anyways, let's go ahead and practice. So example 3 is just answer the question we skipped using this approach, okay? So that's what we'll do. All right, so we're going to practice setting up our formula and then using that, okay? So a sub 1 is just whatever the first term is. So in this case, 6. D, we've already talked about that. Can anybody tell me what D is for this one? 7, okay, counting by 7s. So then our formula, if we kind of sub n, would be like this. We'd say a sub n equals 6 instead of a sub 1 plus n minus 1 times 7. So it kind of looks weird. We're not, usually if we do a monomial times a binomial, it's on the left side, but it means the same thing, okay? Now, we have our general formula. That's why we're going to pretty much skip example 4. So this would be like what we're skipping in example 4. But now we can use that to find a sub whatever. So if we want to find the 11th term, we can use it, right? So now a sub 11 would be 6 plus 11 minus 1 times 7. So once we start using this, I don't usually write it in as 11 minus 1. I'll go ahead and just simplify that to 10, right? And then we just do the math, right? So we just basically have 6 plus 70, right? So 76 here. And you can obviously use your calculator there if you need to. You don't have to do that mentally, but sometimes it's nice and easy, right? So now instead of having to write out, 8 more terms to get to 76, we just use that formula, okay? Does that make sense? Everybody with me on that? All right, we'll do one more together, then you guys try one, okay? All right, so ultimately, well, we'll see. We'll see if it works. All right, anyways, did anybody figure out what that was? 93, that's right. So 90 plus 3 is 93. All right, now I want you guys to try to find the 110th term of the sequence starting with -5, -9, -13. So they give me a sub 1, a sub 2, a sub 3. So what would a sub 110 be? All right, so our general rule would be -5 plus, whatever minus 1 times -4. So if you use that, can you tell me what a sub 110 is equal to? That'd be correct. -441. Anybody want to see that worked out? Perfect. So like I said, we're skipping example 4 because we've kind of already done these. If you want to see more, it's on the filled out notes. Let's finish with finding some missing terms, okay? Finding some missing terms. Tomorrow's notes are pretty much just like this, but different type of sequence, okay? So obviously the problem here would be it's not obvious what our common difference is, right? Between two terms, we just take 125 minus 80, and that would be our common difference. But they're spaced apart, so here's kind of what you need to do on these, okay? So we're given a sub 1 is 80. We need that. We're given a sub whatever else. This would be the fourth term, right? And we can go ahead and plug in 4 for n. So from my starting point, a sub n equals a1 plus n minus 1 times D. Watch what happens when we plug all these values in, right? So we would have 125 equals 80 plus, we know n is 4. And when we sub those three things in, look how many variables we're left with. 1, right? We have a variable. If we ever have a variable, we can solve for that. And that'll be kind of my missing piece, okay? So first step, or I'm going to do a couple things here, is minus 80 from both sides, which is going to give me 45 over here. And, 4 minus 1, we'll simplify that to 3. Now, if we divide both sides by 3, we can see that D equals 15, okay? So basically we just do, we find the difference between 80 and 125, but then, 125 is 3 spots down the line, so you have to divide that by 3 to get that's our common difference is 15. Once you have that, then you just start adding 15s, right? So 80 plus 15 is our next term, 95. 95 plus 15 is our second missing term, which is 110. And then again, you can kind of check it. All right, does 110 plus 115 make 125? Yes. Okay. So these can be tricky, obviously. So you get a chance to do one. We'll probably skip C because of time. I'm going to work B out kind of quietly. You can either copy it or do it and check it. Okay. Lost my notes here. Oh, there. And guys, I'm showing you a really formal approach. There's more than one way to skin a cat, so to speak. That's a weird phrase. But anyways, my way is not the only way. It's just kind of an easy way to show and explain. Okay, so if you have a way that works for you, then that's good too. Okay. Okay, so skipping over C for now. I do, yeah. What'd you have? 44 is correct. Very good. Now, as we move on to our last example, is there an easier way to do C? Anybody see that? Yes. Yeah. 53 minus 35. That's right. So basically, if you're finding a missing term, so you guys said, 53 divided by 53 minus 35. No, it wouldn't be that, right? Yeah. Well, yeah. But is there an even easier way to get 44 directly? It's actually the thing we're about to learn. So it's actually 44 is actually the average of those two numbers. So if you're finding one missing term, or if you look at B, 112 would be the average of these two. That's how you can find the direct middle of two numbers. So that's all the last example is about. So they show this as a kind of a new formula, arithmetic mean. But all it is just the mean, okay? The arithmetic mean is just the average of two numbers. So if you're finding just one missing term, then you can use this, okay? So we'll just finish up with a couple of these and that'd be it, okay? So example 6A is the problem we just talked about was 44. A really direct way to get that is to, again, I can do this because I'm finding one missing term. So what's directly in between them? I can find their average, right? So 35 plus 53 over 2 is whatever it is, right? So that would give you 88 over 2, which is 44. Okay. And sometimes they'll be worded like B, okay? So A sub 5 is this, A sub 7 is that. So find the number in between them. Let's just find their average, okay? So 15 plus 59 divided by 2. So what's that? 74 over 2 be 37, right? Okay, so if you would like, you can try C and D, but I think you probably get the point. I will go ahead and stop the recording here, and hopefully it turns out right with our little technical glitch. But